In 1925, an Egyptian antiquities surveyor named Ahmed Fakhri descended into the subterranean chamber beneath the Great Pyramid of Giza and documented something that would quietly circulate through engineering circles for the next 100 years. The chamber walls, cut directly into the bedrock 30 meters below ground level, were level to within 2 centimeters across a span of over 50 meters. No mortar, no correction passes. The first cut was the final cut. Fakhri was a trained geologist. He understood what that meant. He wrote in his field notes, and this is a documented quote, that the precision, quote, defied any rational account of the tools available. That was 1925. It is now 2024. We still do not have a rational account of the tools available. Before we go any further, we need to establish something. This is not a story about an abstract monument. It is a story about people. Specifically, it is a story about the estimated 20,000 to 30,000 individuals, per the revised 1990 archaeological consensus following the discovery of the workers' village by Zahi Hawass and Mark Lehner, who were assigned to one of the most logistically violent construction operations in human history. These were not enslaved workers in the Hollywood sense. The skeletal remains recovered from the workers' cemetery at Giza tell a documented biological story: healed fractures, surgical amputation evidence on bone, signs of formal medical intervention. The state fed them. The state treated their injuries. Isotopic analysis of their bones, published in the Journal of Archaeological Science in 2013, confirmed they consumed high-quality beef, bread, and fish, proteins consistent with a compensated, organized workforce rather than a coerced labor pool. These individuals gave their bodies, in some cases their lives, to build something. And what they built should not, by any honest engineering assessment, be standing. The fact that it is standing, and standing in the exact condition it is standing in, is the core anomaly we are here to investigate. Let's start with the numbers, because the numbers are where the rational mind begins to fracture. The Great Pyramid of Khufu, the largest of the 3 principal structures at Giza, covers 53,000 square meters of base footprint. Its 4 sides are each approximately 230 meters long. The variance between the longest and shortest side is 4.4 centimeters. That is a dimensional accuracy of 0.019% across a 230-meter span of limestone blocks, each block averaging 2.5 metric tons. Now let us benchmark that figure against the modern world. The Burj Khalifa in Dubai, completed in 2010 using GPS-assisted laser theodolites, computer-aided design software, and a 22,000-person engineering and construction workforce, has a documented dimensional variance across its base footprint that is within an order of magnitude of Khufu's. The Burj Khalifa cost $1.5 billion. The Great Pyramid was built approximately 4,500 years earlier. The alignment data compounds this. The Great Pyramid's 4 sides align to true geographic north, south, east, and west, with a mean angular deviation of 3 minutes and 6 seconds of arc. For reference, 1 degree of arc is divided into 60 minutes. 3 minutes and 6 seconds is 0.052 degrees. A 2001 paper by Kate Spence, published in Nature, proposed that this alignment was achieved by tracking the simultaneous transit of 2 circumpolar stars, Mizar and Kokab, which would have been nearly perfectly aligned with the celestial pole around 2478 BC. This is a plausible hypothesis. It is also, when you actually run the mechanical logistics, an operationally staggering achievement for a culture working with plumb bobs and sighting rods. There is a detail embedded in the alignment data that most general accounts skip over. And this is your breadcrumb. Hold on to it, because we return to it in the final segment. The pyramid's north-facing entrance, located on the 17th course of limestone, is not centered on the north face. It is offset 7.29 meters to the east of center. This is not an error. The offset is too consistent, too precise, and too geometrically intentional to be an accident. No Egyptologist has produced a fully satisfying explanation for the offset. The internal geometry of the descending passage compensates for it. Someone designed the compensation deliberately. We do not know why. Go inside the pyramid. The external precision is documented and well known in engineering circles. The internal architecture is less frequently discussed in public, and it should not be. Above the king's chamber, the primary burial chamber located at roughly the geometric center of the structure, there are 5 distinct compartments stacked vertically, now called the relieving chambers. The lowest is known as Davidson's chamber, discovered in 1765. The upper 4 were not discovered until 1837, when Colonel Howard Vase blasted his way through the solid limestone with gunpowder to reach them. Here is the documented engineering function of these chambers. They collectively redirect approximately 70 metric tons of overhead limestone pressure away from the ceiling of the king's chamber through a distributed load transfer system. The topmost chamber has a pointed, gabled ceiling, effectively a primitive arch, that converts compressive vertical force into lateral force directed into the surrounding rock mass. This is structurally identical, in principle, to the Gothic arch systems formalized in European cathedral engineering, beginning around the 12th century AD, that is 3,500 years after the Giza complex was constructed. The rational interpretation is that Egyptian engineers independently derived an arch load transfer principle through empirical observation. They built things, some of them fell down, and they learned what worked. This is the standard archaeological position, and it is not unreasonable. The anomaly is that nowhere else in the Egyptian archaeological record from this period, not in the Saqqara step pyramids, not in the Dashur structures, not in any contemporary construction, do we see this level of 3-dimensional load engineering applied with this degree of intentionality. It appears at Giza, fully formed, and then it does not clearly propagate forward into the Egyptian construction tradition that follows. Structural engineer Peter Tompkins, in his technical analysis of the internal chamber geometry, documented that the king's chamber walls are constructed from 100 granite blocks averaging 70 tons each. The granite was sourced from the Aswan quarries, approximately 800 kilometers south of Giza. The Nile could transport them by boat during flood season. Getting 70-ton granite blocks from the Nile bank to the interior of a structure that was, by that point, already partially constructed, rising above them, is a logistics problem that has not been fully resolved by any proposed mechanism to this date. It is approximately 2560 BC. You are a site foreman. You are standing in the Tura limestone quarry on the east bank of the Nile, 17 kilometers south of Giza. In your hand is a copper chisel, the hardest tool your civilization manufactures at scale. Copper has a Mohs hardness of approximately 3. The Tura limestone around you registers between 3 and 4 on the Mohs scale. Your tool is the same hardness as, or slightly softer than, the material you are cutting. And yet, you are producing blocks with surface flatness tolerances that a 21st century stonemason, working with diamond-tipped electric cutting equipment, would consider ambitious. You do not know how this is possible. Neither, if we are being precise, do we. The dolerite pounders found at Aswan, rounded igneous rock balls used to pound and bruise granite before copper chisels finish the surface, are real. They are documented. They are the primary proposed mechanism for granite quarrying. They are also, when you run the math on the volume of granite removed and the material removal rate of a dolerite pounder against Aswan granite, insufficient to explain the timeline. A 2018 study published in the Cambridge Archaeological Journal calculated that quarrying the granite used in the king's chamber alone, using only dolerite pounders, would have required approximately 400 workers, operating continuously for 8 years. The entire construction timeline for the Great Pyramid is estimated at 20 years. The granite is one component of a structure containing an estimated 2.3 million stone blocks. You set down your copper chisel, the math does not work. You do not know why the math does not work. You pick the chisel back up, because the deadline does not move, and you keep cutting. The 20-year construction timeline is the mainstream Egyptological consensus. It is derived from the reign of Pharaoh Khufu, which is historically bracketed between approximately 2589 and 2566 BC. If we accept 2.3 million blocks and a 20-year construction window, the math produces a rate of approximately 12 blocks placed per hour, 24 hours a day, 365 days a year, for 2 decades without interruption. Archaeologist Mark Lenner and his team, running experimental archaeology projects at Giza since the 1980s, have demonstrated that organized teams using sledges, water-lubricated limestone surfaces, and ramp systems can move 2.5-ton blocks at competitive rates. Their field experiments produced block movement times consistent with the 12-per-hour hypothesis. This is the strongest empirical evidence for a conventional construction explanation, and it should not be dismissed. The problem is the upper courses. The pyramid tapers as it rises. The logistics of moving blocks at 100 meters elevation, where ramp systems would themselves require a construction volume comparable to the pyramid, have not been experimentally resolved. The internal spiral ramp theory, proposed by French architect Jean-Pierre Houdin in 2007 and partially supported by microgravimetry data collected by a team from EDF, is the most technically credible alternative mechanism currently under active investigation. Ground-penetrating radar surveys conducted in 2017 as part of the Scan Pyramids mission identified a large void, approximately 30 meters long, in the upper section of the pyramid that has not been physically accessed. Its function is unknown. 30 meters. A void the length of a 10-story building is sitting inside the most analyzed structure in human history, and we have not been inside it. The Scan Pyramids team confirmed the anomaly using WAN tomography, the same technology used to peer inside volcanic mountains and nuclear reactors. The Egyptian government has not authorized physical access. The official reason given is preservation concerns. That is a documented fact. What is in the void is not. There are 3 principal theoretical frameworks through which credible researchers interpret the Giza anomalies. Not fringe researchers, not YouTube channels. People with institutional affiliations and peer-reviewed publications. The first is the standard Egyptological model. Egyptian civilization. Over centuries of accumulated engineering knowledge, beginning with early mastaba tombs and progressing through the step pyramids at Saqqara, developed the organizational infrastructure, technical knowledge, and labor management systems to construct the Giza complex within the reign of Khufu. The precision is explainable through sophisticated but low technology methods, water levels, plumb bobs, sighting rods, and an extraordinarily well-organized workforce. The anomalies are real but not inexplicable. We simply haven't recovered all the evidence yet. The second framework is the lost civilization hypothesis, most prominently associated with researchers Graham Hancock and Robert Schoch. The Giza complex in this model reflects engineering knowledge that predates Khufu, potentially by thousands of years, inherited or preserved from an earlier, more technically sophisticated culture that does not appear in the standard archaeological record. Schoch's geological analysis of the weathering patterns on the Sphinx enclosure, peer-reviewed in the Journal of the Geological Society of America in 1991, argues that the erosion pattern is consistent with rainfall weathering rather than wind and sand erosion, which would push the construction date of the Sphinx to a period when Egypt received significantly more rainfall, roughly 9,000 to 5,000 BC. This remains a genuinely contested geological argument. It has not been resolved. The third framework is the most conservative and the one least discussed and popular. Media, the institutional knowledge gap. We simply lost the records. Egyptian civilization was literate. It was bureaucratic. The Wadi al-Jarf papyri, discovered in 2013 and published in 2017, contained the operational diary of an inspector named Mirror, who supervised teams transporting limestone from Tura to Giza during the pyramid's construction. This is a first-person contemporary account of the operation, the oldest papyrus documents ever discovered. They describe the logistics in functional, bureaucratic detail. They do not explain the precision. The technical manuals, if they existed, have not been recovered. The Library of Alexandria, destroyed in a sequence of incidents between 48 BC and 642 AD, reportedly contained Egyptian technical documents of significant antiquity. We will never know what was in them. Return to the entrance offset. The 7.29-meter displacement of the north entrance from the center of the north face. We flagged this detail earlier. Here is what that number actually means when you run it through the pyramid's internal geometry. The descending passage, which begins at the offset entrance and runs at a 26.5-degree angle downward into the bedrock, is oriented such that, when extended upward through the pyramid's theoretical apex, it produces a line of sight that, at the time of construction, approximately 2560 BC, pointed directly at the celestial North Pole as defined by the stars of that era. Not magnetic north, celestial north. The offset at the entrance is not an error in the base geometry. It is a correction that compensates for the relationship between the entrance elevation, the passage angle, and the desired terminal sighting point in the sky. Whoever designed this structure understood three-dimensional angular geometry well enough to calculate, in advance, the effective entrance elevation on a passage alignment target over 100 meters away and bake that correction into the original foundation layout. That is not primitive engineering. That is not achievable by accident. That is the output of a mind, or a group of minds, operating at a level of geometric and astronomical sophistication that we do not have a satisfying historical account of. The Great Pyramid of Giza has been standing for approximately 4,500 years. It is the oldest of the 7 wonders of the ancient world and the only one still intact. Every other wonder, the Hanging Gardens, the Colossus of Rhodes, the Lighthouse of Alexandria, is gone. The pyramid remains. Not because it was lucky, because it was built to remain. The unanswered question is not whether ancient Egyptians built it. The archaeological consensus is clear. They did. The unanswered question is what they knew that we do not. Because the structure they left behind encodes knowledge, geometric, astronomical, structural, that we are still in the process of decoding. And inside that pyramid, right now, there's a 30-meter void that no living person has entered. Whatever is in that void has been waiting 4,500 years. It is still waiting.